and low energy in their reaction.
Hello, thank you for the opportunity to give this talk. Hoffman shell particles are particles, this is very common in relativistic quantum mechanics. These are particles that don't have the ordinary rest mass. Usually they're called virtual particles in the literature. And it's a standard thing in quantum field theory, elementary particle physics, etc. Many anomalies have been observed in your experiments at LNR research, but there's a severe skepticism by physicists. Not me, I'm not one of them skeptics, but I am a physicist. And the literature is very complicated, your literature. And the proposed explanation here is based on two peer-reviewed physics papers, both accepted. One in Foundations of Physics came out last year in May, and the other one will come out in a few months, I guess, by Institute of Physics, Journal of Physics. So, experimental claims in LNR conflict with conventional nuclear and condensed matter physics. That's what most people in physics think. Despite many proposed theories from these fields, there's no consensus, and none of these has gained any significant acceptance by the physics community. And I don't think there's any argument about that here either. Particle physics and relativistic quantum field theory are the parent fields of both nuclear physics and condensed matter physics. There may be an argument about that, but that's what particle physics think, physicists think anyway. And the resolution of this dilemma will most likely come from them. But certainly any proposed theory must be approved by them to be acceptable, because nuclear reactions are elementary particle reactions. So it has to be copacetic with this particle physics community. Relativity is required to describe nuclear events. The standard model of particle physics is a relativistic quantum field theory, with the key word being relativistic there. And every nuclear event involves, some aspect of the standard model. The standard model is believed to describe exactly what we observe in nuclear physics. And for example, the neutron-proton mass difference has recently been very accurately calculated in a paper using lattice QCD, which is a way of solving the standard model. Only a few small volumes that we observe in these metals are actually reactive. And these locations have been called the nuclear active environments by Ed Storms and others of you, and I think we all agree that they exist. They usually occur near a surface of a metal, although that may be debated as well. And as we all know, there's well-known difficulties, for example, in describing DD fusion. And I understand there's also some other reactions one can look at, but DD fusion is a big one in this community. And, Kunin did a calculation based on deuterium, modeling it after the muon catalyzed fusion, and calculated 50 orders of magnitude too low a fusion rate to agree with Pons and Fleischmann. And Leggett and Bain, again, great scientists, all of them, agreed with this result. So in other words, LNR and physics disagree by 50 orders of magnitude. And I believe that's correct. Existing theory does disagree with the experimental